Hello, everyone. Another video for operations planning and control. In this video, we will be talking about the scheduling techniques. The scheduling techniques is one of the strategies that we use to meet the customer needs. Just as a reminder, let's say how is the different planning and strategies fits together. So we start with the aggregate planning. Of course, I don't want to remind you that there is something before the aggregate planning, which is the strategic plan, the financial visibility, the KPI, using the SWOT analysis to understand the environment. Now, we passed that phase. We're going into the aggregate plan, and the aggregate plan is the overall demand. We're looking into the bigger picture of the demand, the needs. And of course, we match it with the capacity and so on. Now we're moving down to the line to find out what would be the master production schedule, which is for individual items. So we break it down into individual items. And now even we dig it deep into the material requirement planning, where we look into even the subcomponent and the subparts that we need to make the products to meet the demands. And now, once we have all this, we need to talk about scheduling, where we create the schedule to build the schedule. We talk about the timing to build the schedule and in order to meet the demand on the same time. Of course, the difference between manufacturing and service, we're still going to follow these steps. However, we don't have a material requirement planning in the service. We have a monthly or weekly schedule, and then we have a daily schedule to meet the demand. All right, there are two different scheduling techniques that we use. One is the backward scheduling. This is the typical approach that we use. We start with the due date and then use the lead time to find when would be the start date. Also, there is another technique called the forward scheduling, which is launch the order into the first gateway work center, then use that lead time to find out when the order will be ready and available to the customer. So the first one, the backward scheduling, we start with the due date and we go back based on the lead time to find out when should be the starting date. However, the forward scheduling, we have the starting date and we count for the lead time, and then we know exactly when the order would be available. All right, let's take a look into the back scheduling or the backward scheduling. An order of 150 of component is due on 135. So that's the due date is day 135. An order starts at the beginning of the day and finishes at the end of the day. Operation times for the 150 orders would be we need 4 days in work center 12. That's we're going to use operation 10. We need 5 days in work center 14. We need 1 day in work center 17, and we need 2 days in work center 3. All right, now moving into down here, let's take a look into how we could move these around. We have queue time, wait time, and move time as well in each of these work centers. Again, we have a work center 12, 14, 17, and 3, and this is given from here, 12, 14, 17, and 3. And now we look into the queue time, the wait time, the move time, in additional to the operations time, which is how long will take you to finish out of that operation. So in order to build the schedule, we start with the due date, which is 135. We're going to start with a 135, which is given to you here in this slide. Right here, this is the due date. So we build the schedule for starting from 135 to be available to the customer to be sent to the store. Okay, now we start with operation number 40, 30, 10, and 10. And the work center is 12, 14, 17, and 3. This is given. All right, so now let's start with 133. The finish date for operations number 40, which would be 133. Why is 133? Because we have a move time 1 day and a wait time for 1 day. So this is where the 133. And then we look into the operations. When would be the starting date? That would be 123 here. And then, so we have to start with operation 40 at work center 3 on day 123. And then also we go back to the finish date, 2 days because of the wait time, which is 121, and then 121 minus the operations, which is 1, and the Q, which is 5. So that will give you 115, and then 113. That would be the finish date for operations 20, and 105 would be the arrival date, and go back 2 days, that 103. So in order to finish this on 100 and day 135, we have to start on day 95. All right, let's get into more details. I did added another column here to give you an idea on what you should include, and I did rearrange these columns. So, and also I want you to use these equations. So in order to know the finish date would be the arrival date on the next step minus the wait time minus the wait time. All right, so 135 minus the wait time, it's 1, minus the move date is 1. So that would be 133 is the finish date for operations 40. Now for the arrival date, which is, as you see here, 123, that would be the finish date 133 minus the operations time minus the queue time. So we have 133 minus 2 minus 8, which will give you 123. Now let's go ahead and do the finish date, which is 123 minus these 2 days. That will be 121. And go back 6 days. That will give you 115. And then move to the next one. Again, we're moving backwards. So 113 would be the finish date here. And just 115 minus 2 days. And then go back 8 days to find out the arrival date should be 105. And then from here, the finish date is 103 because of 105 minus 2 days, the move date, wait minus the wait. And then the arrival date would be 103 minus 8 to give you 95. This would be the arrival date. So this process should start on day 95. All right, here is another chart that we could use the graph to demonstrate when would be the due date. So we have 135, operation 40. This is how much it will take, and consider the move and wait time as well and the process. And therefore, we found out the 95 would be the release date. So this is where we have to issue the order saying to the manufacturing, you can go ahead and start production. And in this way, we could make this product available on day 135. Now, let's take another example on a backward scheduling when we have a company has an order for 50 brand X. So we have a brand X, we have 50 orders to be delivered on day 100. So that's the due date, 100. Only one machine is available for each operation. The factory works on 1 8-hour shift, 5 days a week. The part moves in one lot of 50. So we have lots of 50. So we have this product X that consists of A and B. So in order to make X, we need A and B. A needs 2 operations, 10 and 20, with a time of 5 and 3. B, we have operation 10, which needs a time of 10. X, once we have A and B, we have the assembly for X to have 5 days. All right, so now here's the backward. We start with a 100, go back 5 days for the assembly. That will leave you at a 95. And now we have a part A and part B. Just use the tree structure table, which is right here, and flip it on a side and start do the planning. So 100 minus 5, that would be 95. 95. Now for operation, for part B, we need operation 10, which will take 10 days. So we have to do 85 here. And then for part A, we need operation 20, which will take 3 days. So we'll start with that, 3 days. And then, so that would start on 92, and then go back another 5 days, which would be 87. So the starting date for this assembly to make the product available would be on day 85. All right, so I'm going to stop right here. This is just an example on the backward scheduling. And what we need to do next is to talk about some controlling process and how we could set priorities to match the plan with the actual performance. I'll see you in another video.